Are you struggling to break down complex algorithmic problems into manageable pieces? Most coding interviews at top tech companies rely heavily on your ability to master the divide and conquer strategy. In this video, we will cover divide and conquer algorithms DSA practice questions and answers. Master divide and conquer algorithms with this comprehensive practice guide. In this video, we dive deep into 30 essential practice questions covering the divide and conquer paradigm, including recursion, master theorem, and classic algorithms like merge sort and quick sort. Before we begin, make sure to grab a notebook. If you find these questions helpful, don't forget to hit the like button and subscribe for more DSA content. Which of the following is the fundamental three-step process of a divide and conquer algorithm? Option A, divide, sort, merge. Option B, divide, conquer, combine. Option C, split, solve, backtrack. Option D, iterate, recurse, return. The correct answer is B. The divide and conquer paradigm consists of three main steps. 1. Divide, breaking the problem into smaller subproblems that are similar to the original problem. 2. Conquer, solving the subproblems recursively. If the subproblem size is small enough, base case, solve it directly. 3. Combine, merging the solutions of the subproblems to create the solution for the original problem. This is the standard definition used in academic computer science and algorithm design. What is the time complexity of a divide and conquer algorithm defined by the recurrence T? N equals 2T, N 2 plus N? Option A, O, N. Option B, O, log N. Option C, O, N log N. Option D, O, N squared. The correct answer is C. Using the Master Theorem, T, N, equals at, N, B, plus F, N, where A equals 2, B equals 2, and F, N, equals N. Here, N caret, log underscore BA, equals N caret, log underscore 22, equals N caret 1. Since F, N, equals N caret 1, this falls into case 2 of the Master Theorem. When F, N, matches N caret, log underscore BA, the complexity is O, N caret, log underscore BA, asterisk log N, which simplifies to O, N log N. This specific recurrence relation describes the behavior of algorithms like merge sort. In quick sort, what is the effect of choosing the smallest or largest element as the pivot consistently? Option A, it results in O, N log N, complexity. Option B, it results in O, N squared, complexity. Option C, it improves the performance of the algorithm. Option D, it makes the algorithm stable. The correct answer is B. Quick sort relies on partitioning the array into two roughly equal halves to achieve O, N log N, performance. If the pivot is always the minimum or maximum element, one partition will have 0 elements and the other will have N1 elements. This leads to a highly unbalanced recursion tree with a depth of N, resulting in a worst-case time complexity of O, N squared. Randomized pivot selection is usually used to prevent this. What is a primary difference between divide and conquer in dynamic programming? Option A, divide and conquer is always faster. Option B, dynamic programming is used when subproblems overlap. Divide and conquer is for non-overlapping subproblems. Option C, Divide and conquer uses memoization. Option D. Dynamic programming does not use recursion. The correct answer is B. The key distinction lies in the nature of the sub-problems divide and conquer is best suited for independent sub-problems. Like in merge sort, if sub-problems are redundant, overlapping, divide and conquer would solve them multiple times, leading to inefficiency. Dynamic programming solves each subproblem once and stores the result. Memoization, tabulation, to avoid redundant work. Which of the following sorting algorithms is not typically implemented using the divide and conquer strategy? Option A, merge sort. Option B, quick sort. Option C, bubble sort. Option D, heap sort. The correct answer is C. Bubble sort is an iterative, comparison-based algorithm that repeatedly steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. It does not divide the problem into smaller subproblems. Merge sort and quick sort are the textbook examples of divide and conquer. While heap sort uses a tree structure, it is categorized more as a selection-based sort using a data structure rather than a classic divide and conquer approach. Binary search follows the divide and conquer strategy. What is its recurrence relation? Option A, T, N equals 2T, N 2 plus O, 1. Option B, T, N equals T, N 2 plus O, 1. Option C, T, N equals T, N 1 plus O, 1. Option D, T, N equals 2T, N 2 plus O, N. The correct answer is B. In binary search, the algorithm divides the search interval in half. However, unlike merge sort, it only conquers one of the halves, the one that could contain the target. Therefore, it makes only one recursive call on a problem of size n. 2. The combine, or divide, step, comparing the middle element, takes constant time O, 1. This results in T, N equals T, N 2 plus O, 1, which solves to O, log n. Strassen's matrix multiplication reduces the number of recursive multiplications from 8 to Option A, 4. Option B, 6. Option C, 7. Option D, 9. The correct answer is C. The standard divide and conquer approach for multiplying two 2x2 matrices requires 8 multiplications and 4 additions. Strassen's algorithm uses a clever mathematical manipulation to reduce the number of multiplications to 7, at the cost of more additions. This reduction changes the recurrence from T, N equals 8T, N 2 plus O, N squared, to T, N equals 7T, N 2 plus O, N squared, improving the time complexity from O, N cubed, to approximately O, N squared. 81. In the Master Theorem, if f, n, equals O, n caret c, where c less than log underscore ba, what is the complexity? Option A, T, N, equals theta, n caret c. Option B, T, N, equals theta, n caret, log underscore ba. Option C, T, N, equals theta, log n. Option D, T, N, equals theta, n log n. The correct answer is B. This corresponds to case 1 of the Master Theorem. If the work done at the root, f, n, is polynomially smaller than the work at the leaves, n caret log underscore ba, then the complexity is dominated by the cost of the recursive calls, specifically the number of leaves in the recursion tree. Thus, the total time complexity is T n equals theta n caret log underscore ba. What is the auxiliary space complexity of a standard merge sort implementation? Option A, O, 1. Option B, O, log n. Option C, O, n. Option D, O, n squared. The correct answer is C. Standard merge sort requires an auxiliary array to store the merged elements before copying them back to the original array. During the combine step, the total extra space needed at any level of recursion is proportional to the number of elements being merged. While there are in-place versions of merge sort, they are complex and often increase the time complexity. Therefore, the standard version is O, n. Which of these is a significant disadvantage of the divide and conquer approach? Option A. It cannot be parallelized. Option B. Recursion overhead can lead to high stack memory usage. Option C. It is always slower than iterative approaches. Option D. It only works on sorted data. The correct answer is B. Divide and conquer is naturally recursive. Each recursive call adds a new frame to the call stack. For very large datasets or deep recursion, like O, n, depth in worst-case quick sort, this can lead to a stack overflow error. While iteration can often replace recursion to save space, the fundamental divide logic usually requires managing some form of explicit or implicit stack. What is the time complexity of the divide and conquer algorithm for finding the closest pair of points in a 2D plane? Option A, O, n. Option B, O, n log n. Option C, O, n log squared n. Option D, O, n squared. The correct answer is B. A naive approach checks every pair. Taking O, n squared. The divide and conquer approach sorts points by x coordinates, splits them, finds the minimum distance d in each half, and then checks the strip near the dividing line. By sorting the strip by y coordinates, we only need to check a constant number of points for each point in the strip. This yields T n equals 2T n 2 plus O n, which is O n log n. Which phase of merge sort involves the most computational work? Option A, divide. Option B, conquer. Base case. Option C, combine. Merge. Option D, all phases are equal. The correct answer is C. In merge sort, the divide step just calculates the midpoint, which is O, 1. The conquer step is just recursive calls. The real work happens in the combine, merge step, where elements are compared and moved into a new array. This step takes O, n, time at each level of the recursion tree, making it the most expensive part of the process. Quick sort is known as an in-place sorting algorithm. What does this mean? Option A, it doesn't use recursion. Option B, it uses a constant amount of extra space, ignoring stack space. Option C, it does not change the order of equal elements. Option D, it sorts the array in O, n, time. The correct answer is B. An in-place algorithm transforms the input using no auxiliary data structure, other than a small amount of extra storage for variables. Quicksort partitions the array by swapping elements within the original array itself. Note that it still uses O log n space on the recursion stack, but compared to merge sort, which requires an O n auxiliary array, it is considered in place. Which algorithm uses divide and conquer to find both the maximum and minimum elements in an array, with fewer comparisons than the naive approach? Option A, tournament method. Option B, linear scan. Option C, randomized select. Option D, Strassen's method. The correct answer is A. The tournament method, a divide and conquer approach, divides the array into pairs, finds the max per minute of each pair, and then recursively finds the max per minute of the results. This reduces the number of comparisons from approximately 2n to about 3n, 2. While it's still O(n), the constant factor improvement is useful in competitive programming and system optimization. What happens if a divide and conquer algorithm does not have a base case? Option A, it returns 0. Option B, it runs in O(1) time. Option C, it results in infinite recursion. Option D, the compiler automatically fixes it. The correct answer is C. The base case is essential in recursion to stop the divide process. Without it, the algorithm would continue to call itself with smaller or equal arguments indefinitely, or until the system's call stack is exhausted. This results in a stack overflow error in most programming environments. If an algorithm divides a problem of size n into 3 subproblems of size n, 4 and the work to combine them is O(n squared), what is the complexity? Option A, O(n squared). Option B, O(n caret log underscore 43). Option C, O(n cubed). Option D, O(n log n). The correct answer is A. Using Master Theorem, A equals 3, B equals 4, F, n equals n squared, log underscore BA equals log underscore 43, which is less than 1. Since F, n equals n squared and 2 greater than log underscore 43, this is case 3. We check the regularity condition. 3, n, 4 squared less than equals kn squared. This holds for k equals 3/16. Therefore, the complexity is dominated by the work at the root, which is theta. F, n equals O(n squared). Which version of quicksort is generally preferred to avoid the O(n squared) worst case on already sorted arrays? Option A, deterministic quicksort with first element as pivot. Option B, randomized quicksort. Option C, quicksort using a stack. Option D, merge sort. The correct answer is B. Randomized quicksort chooses a random element as the pivot. This makes it highly unlikely to consistently pick the smallest or largest element, even on sorted or nearly sorted inputs. This ensures that the expected time complexity is O(n log n), regardless of the initial order of elements. Which algorithm uses divide and conquer to multiply two polynomials in O(n log n) time? Option A, Karatsuba algorithm. Option B, fast Fourier transform, FFT. Option C, binary search. Option D, Selection sort. The correct answer is B. Standard polynomial multiplication takes O(n squared). The fast Fourier transform (FFT) uses a divide and conquer approach to convert polynomials from coefficient form to point value form, multiplies them in linear time, and converts them back. The transformation steps take O(n log n), resulting in a much faster overall multiplication for large-degree polynomials. The Karatsuba algorithm improves integer multiplication from O(n squared to approximately Option A, O(n log n). Option B, O(n caret 1.58). Option C, O(n caret 1.41). Option D, O(n). The correct answer is B. Karatsuba multiplication is a divide and conquer algorithm that reduces the multiplication of two n-digit numbers to 3 multiplications of n two-digit numbers, instead of the 4 required by the standard approach. The recurrence is t n equals 3t n 2 plus O(n). By Master Theorem, this is O(n caret log underscore 23, which is approximately O(n caret 1.58). What is the stability of the standard quicksort algorithm? Option A, stable. Option B, unstable. Option C, depends on the pivot. Option D, depends on the array size. The correct answer is B. A sorting algorithm is stable if it preserves the relative order of elements with equal keys. Standard quicksort involves swapping elements across long distances to partition the array around a pivot, which often changes the relative order of identical elements. Therefore, it is generally considered unstable. What is the base case in a divide and conquer algorithm? Option A, the largest possible input size. Option B, the condition where the problem is small enough to be solved directly without further recursion. Option C, the first step where we divide the array. Option D, the part where we combine the results. The correct answer is B. Every recursive algorithm needs a termination condition. In divide and conquer, we keep splitting the problem until it reaches a size where the answer is trivial. E.g., an array with one element is already sorted. This is the base case. Without it, the algorithm would recurse infinitely. In a sorted rotated array, which algorithm can find the minimum element in O log n time using divide and conquer? Option A, linear search. Option B, modified binary search. Option C, exponential search. Option D, jump search. The correct answer is B. Even if an array is rotated, e.g., 4, 5, 6, 7, 0, 1, 2, we can still apply the logic of binary search. By comparing the middle element with the rightmost element, we can determine which half contains the inflection point or the minimum element. This maintains the O log n complexity characteristic of divide and conquer searching. Merge sort is typically preferred over quick sort for sorting linked lists because Option A, linked lists have slow random access, making quick sort partitioning inefficient. Option B, merge sort is in place for linked lists. Option C, merge sort doesn't require extra space for linked lists. Option D, both A and C are correct. The correct answer is D. Quick sort relies on indexing, random access, to pick pivots and swap elements efficiently. Linked lists only support sequential access, which hurts quick sort. Conversely, merge sort can be implemented for linked lists without the O(n) auxiliary array, only needing O log n stack space, and works well with sequential access patterns. Which algorithmic paradigm does the merge part of merge sort belong to? Option A, greedy. Option B, dynamic programming. Option C, two pointers. Option D, backtracking. The correct answer is C. While the overall algorithm is divide and conquer, the merge step specifically uses the two pointers technique. It maintains a pointer for each of the two sorted subarrays and moves the pointer of the smaller element forward to build the combined sorted array. What is the recurrence for the median of medians algorithm used for selection? Option A, T n equals T n 5 plus T 7 n 10 plus O n. Option B, T n equals 2T n 2 plus O n. Option C, T n equals T n 2 plus O 1. Option D, T n equals T n 1 plus O n. The correct answer is A. The median of medians is a divide and conquer selection algorithm. It ensures a good pivot by 1. Dividing into groups of 5 and finding medians. T n 5. 2. Finding the median of those medians to use as a pivot. 3. Partitioning. The worst case split is 70/30ths. Hence T 7 n 10. The work for grouping and partitioning is O n. This results in a linear O n. Worst case time complexity. In quicksort partitioning, if all elements in the array are identical, what is the complexity for a basic implementation? Option A, O n. Option B, O n log n. Option C, O n squared. Option D, O log n. The correct answer is C. In a basic Hor or Lomuto partition, if all elements are the same, the partition might always return the end of the range, leading to a highly unbalanced tree. This results in O n recursive calls, each doing O n work, totaling O n squared. Modern implementations use three-way partitioning to handle duplicate keys in O n time. What is tail recursion, and can it be applied to divide and conquer? Option A. It's when the recursive call is the last action. It's difficult for DNC because DNC usually needs to combine after calls. Option B. It's when the base case is reached. It is the core of DNC. Option C. It's a way to eliminate the divide step. Option D. It's only used in dynamic programming. The correct answer is A. Tail recursion occurs when the recursive call is the very last statement in a function, allowing the compiler to reuse the stack frame. In divide and conquer, like merge sort, you usually have two recursive calls followed by a combine step. Because the combine step happens after the call's return, these algorithms are not naturally tail recursive. Which sorting algorithm is external? Can sort data that doesn't fit in RAM using divide and conquer? Option A, quicksort. Option B, merge sort. Option C, selection sort. Option D, insertion sort. The correct answer is B. External merge sort is the standard for sorting massive datasets, like database files, stored on disk. It works by dividing the file into chunks that fit in RAM, sorting them, and then using the merge logic to combine the sorted chunks from the disk into a single sorted file. Which of the following problems can be solved using a divide and conquer approach? Option A, finding the maximum subarray sum. Option B, Tower of Hanoi. Option C, inversion counting. Option D, all of the above. The correct answer is D. All these problems utilize divide and conquer. Maximum subarray sum can be split into left, right, and crossing sums. Tower of Hanoi is a classic recursive division problem. Inversion counting is typically implemented as a modification of the merge sort combine step. If an algorithm divides a problem of size n into two subproblems of size n, 2 in the combination step, as O(1), what is its complexity? Option A, O, n. Option B, O, log n. Option C, O, n log n. Option D, O, 1. The correct answer is A. Recurrence. T, n, equals 2t, n, 2, plus O, 1. Using Master Theorem. A equals 2, B equals 2, F, n, equals 1. Log underscore BA equals log underscore 2 equals 1. Since F, n, equals n caret 0 and 0 less than 1. This is case 1. The complexity is theta, n caret, log underscore BA, equals theta, n caret 1, equals O, n. That wraps up our 30-question marathon on divide and conquer algorithms. How many did you get right? Let us know your score in the comments. If you want to master more DSA topics, check out the full course and practice exams linked in the description. For the full practice exam and certification materials, check the link in the description below.